Alright, so what I want to do is I want to review particle motion. And what's important about particle motion is few things that you must know. Is the direction, and also for now, just for now, because there are more things you need to know, the direction that is taking it. Is it moving to the left? Is it moving to the right? Also, the time when the object or the particle has stopped. Or we can also say the same thing, that is that the object is at rest. The next thing you gotta know is whether the particle is slowing down or if it is speeding up. Okay, so we want to know three things for now. So we're gonna start with displacement. Displacement is basically how far you moved from where you started. And so basically I went from one interval from A to B. So displacement, you can think of it as S of B minus S of A. But you know, where A is the initial time and B is the final time, or you can just think of it as S of final time minus S of initial time. Okay, so that's where we are. The first thing now is the direction. And every time they talk about direction, you have to think of your velocity function. And you gotta know a few things about velocity. When v of t is less than 0, when v of t is greater than 0, what's happening with the object? When v of t is less than 0, when it's negative, we can think of it as that the object is either moving left, depending on the context of the problem. So you got to read it. They're going to ask you, is it moving to the left or to the right? Or they might ask you, is it moving up or down? Or is it moving forward or backwards? So you got to basically understand what the problem is asking you to do. So left or down or backwards. Okay? When it's positive, you can, it's either to the right or up or forward. So those are a few things you're going to know. When v of t equals 0, that's when we say that basically, it makes sense. The particle has stopped or is at rest. Okay? Now, so that's one. When you have questions like if it is speeding up or if it is slowing down, we have to think of two things, v of t and a of t. We have to think of the sign of both functions. So same sign, v of t and a of t. So positive, positive, negative, negative, that means that the particle is speeding up. When they have different signs, v of t, a of t, positive, negative, negative, positive, then the object is slowing down. So, okay. Now, let's do one problem. So, example. Example 1. let's say you have a position function, which I'm gonna describe it as s of t is t squared minus 7t plus 12. I'm going to ask you for the velocity function at any time t. So v of t at any time. So the notation that you can use is either you can write s prime of t, you can write v of t, or you can also write ds over dt, the derivative of the position function with respect to time. So any of this is okay. So now I'm adding a new one here. Either one is fine. So you don't have to write all of them. Just select one that you feel comfortable with, but you make sure that you know the proper notation. So any one that you select, so it will be the derivative of your position function, which is basically 2t minus 7. You don't have to write units. This is just the velocity at any given time. You write the units when they give you a specific time to evaluate the velocity function. So now let's say I ask you for the acceleration function, and again you can write s double prime of t, or you can write v prime of t, or you can write the second derivative of the position function with respect to time. So any of this is just fine. So just again pay attention to the notation that you feel comfortable with, but make sure that you know the proper notation. So here we go. So acceleration is the derivative of your velocity function. In this case, you'll get just 2. Now you can now answer the question whether it is speeding up, it is slowing down, because now you have the velocity function, the acceleration function, and you can evaluate a particular time they give you. So let's say at t equals 3. Is the particle slowing down or speeding up? So I want to know if it is speeding up or slowing down. Okay, either one. Now, so I want to know v of 3, and that is 2 times 3 minus 7. That gives you 6 minus 7, that gives you -1. In this case, you do have to worry about the units. So let's say the units for position function, let's say we start from t equals greater than or equal to 0, and it was centimeters per second. Okay, so in this case, centimeters per second. A of t is going to be a of 3. It's just going to be 2 for any t time that you put in there. It's always going to be just 2. And in this case, centimeters per second squared. So be careful with that power of 2. Okay? Now we're ready to answer the question whether the object is speeding up or slowing down. So since v of 3 is less than 0 and a of 3 is greater than 0, the object or the particle is slowing down, different sign, and at t equals 3. Okay. Next, I can also ask you, let's continue with the same position function, t squared minus 7t plus 12. I want to know, is it moving to the left, or is it moving to, when is it moving to the right, and when is it at rest, or it has stopped. Okay. All right, so this is basically v of t function. So v of t, we already know that is 2t minus 7. So first you need to know when it stops, because in order to change direction, you basically have to stop before you change any direction. So set the velocity function equal to 0. V of t equals 0, so I want to know when it has stopped. So 2t minus 7 equals 0, so 2t equals 7, so t equals 7 over 2. So I know that at t equals seconds, by the way, t equals 7 over 2, or 3.5 seconds, the object has stopped. So now, since you're given that the time starts is from 0, you do a sign chart for velocity function, and I know that I start from 0 is given right here, and I know that it basically stopped at 7/2. So what I want to know now is what happened from 0 to 7/2. Was it on the left? Was it on the right? What happened there? But I know that at 7/2 or 3.5 seconds, the object basically has stopped. Okay? Now, to find out whether it moved to the right or to the left on any of these intervals, we have to try a number between 0 and 7/2 between this interval. So you now have to select a number from this interval and plug it into your velocity function. So let's say I select 1. That will give you 2 times 1 is 2 minus 7. That will give you -5. That means this is negative. So now let's try the other one, the other interval from here to infinity. So we have, let's say 4. 2 times 4 is 8 minus 1 is positive. So now you know that this particular sign tells you something, because we know that when velocity is positive, it moves to the right, up, forward, negative, left, down, backwards. So in this case, I want to know the interval when it moves to the left. So you say the particle moves to the left. So it moves to the left on the interval. So make sure you say the particle moves to the left on the interval from 0 to 7/2. But then you have to justify it. And the justification is since v of t is less than 0. The particle moves to the right on the interval from 7/2 to infinity. And the justification is because v of t is greater than 0. Okay? So now you should have a better understanding of particle motion by understanding velocity's direction, also when it stops, and acceleration with velocity together. When you look at the signs of the two functions, you can now tell me if the particle is speeding up or slowing down. So this is just a basic introduction to particle motion. Okay.